welcome to another episode of the Some Engineering Podcast. And today we have Mike Driscoll, who's the founder and co-founder and CEO of Rill Data. And because this is casual, this is how we do these intros. All right, so Mike, we're going to talk about Rill Data. So let's dive right in. Tell us what Rill Data.
Yeah, so Rill Data, we are on a mission to radically simplify how developers create operational dashboards. And we have been working for the last, I would say, almost a year now on a new product called Rill Developer, which is really aimed at making that promise come true. We just released yesterday morning the .16 version of Rill Developer, which very simply is a way to take SQL and YAML, attach it to a data lake, and get a dashboard. So I'd love to just dive right in and show the product.
Best way to do it. This is why we do this. This is why we do it on video. I love it. Let's go.
Exactly. So let's show it off. I'll start with let me bring my browser up here, and I'll pull this up. This is
While you do that,
that guy. Well, go ahead. Yeah.
While you do that, I'm going to do a little bit of talking on when we prepped. I took some notes, right? And if we're thinking about the usual trifecta of a data pipeline, a database, and a dashboard, and today how the modern data stack sort of has all these different components that you need to stitch together, then Rill Data is that one solution in one complete full stack, right? Which you can run on your laptop if you want to. And then there's also the enterprise edition. So it's really about simplicity.
That's right. That's the kind of core value prop here is that we really want to take that journey, which today takes multiple people and multiple systems. You need an ETL tool. Even for that last mile of data, you need often a data warehouse, and you need sometimes a semantic layer, a data catalog,
yes,
and ultimately a dashboard tool. So there's just a lot of complexity, and we're trying to really distill that down. There's really what inspired a lot of this work is we have an investor. I'll now share my screen so we can all kind of look at. So we have an investor named Josh Wills, who back in October said, hey, while I wait for top code data to be open sourced, what's the best declarative SQL plus YAML way of creating a simple dashboard against DuckDB? Rill Data, could you help me out here? And so yesterday we said, hey, Josh, good news. SQL plus YAML equals dashboard. We officially launched that. The dream here is BI as code. We know that a lot of folks on your podcast have talked about infrastructure as code. We've seen other areas really become more and more code dominated. And we've also seen really the rise of DuckDB as an incredibly powerful embedded OLAP database, really like what SQLite is for OLTP, DuckDB is for OLAP. So let's actually go in and see, let's give this product a spin.
Yes.
So you can click here. This is our docs page. You can go through and read this, but let's actually just go right in and figure out how we can install Rill and get started. So It's pretty simple.
Do you want to go on full screen, Mike?
Oh yeah, sure, of course.
Let's go on full screen.
There you go.
There you go. Yeah.
So let's pick an install option. We're just going to do a curl command. One of the things we're really proud of at Rill is that this binary is quite lightweight. So this curl command just basically auto detects which binary you should pull down and it's less than 100 megs. That's it. Rill's been installed here.
It's pretty light.
Yeah, pretty lightweight. So if we go and say, all right, what's our what do we want to do next here? You can initialize an example. I'm actually going to start, because I actually know how this build product works. I'm actually going to just start and build a dashboard from scratch. So the example we're going to give here is going to be, we're looking, by the way, do you want this to be full screen too?
This is good. We can see it like that. I think this is
great.
fine. Yeah.
So let's go ahead and create a, I'm going to create a project called, let's call it commerce, commerce metrics. So we're going to make a new project, a Rill dashboard that's about e-commerce. So nothing's in that directory. We're going to do a Rill init. Again, it's going to initialize this project. You can see here what it's built is really Rill operates on kind of three kinds of code artifacts. There's artifacts that talk about the sources of data. That's where the data comes from. Typically, that's an object store like S3 or Google Cloud Storage. Models are the way that we often stitch these sources together and materialize them into our system. And those models are in Rill Developer running on localhost. They're materialized in DuckDB. And then finally, the dashboards. So the models are SQL. The dashboards are YAML. So that's where you get the sort of SQL plus YAML equals dashboard. So let's actually go ahead and do a Rill start here. We've initialized. So that should, that opens up Rill Developer. You can see it here. So again, sources, models, dashboards, right? Each of these are going to be some artifacts that we're going to work with. So I going to go through an example where I'm going to pretend I'm running an e-commerce shop. Actually, for what it's worth, my first company when I graduated from college in 1998, that was back when e-commerce was a thing. My first company out of college that I started was a t-shirt business called custominc.com. So,
no way. You started Custom Ink?
Yeah.
Get out.
Yeah. So
no way. Okay.
Yeah. So many of our listeners might occasionally buy t-shirts for their swag for their company. If you go to Custom Ink, you'll see thank you for your business. But my college roommate still runs that today. Fast forward, almost 25 years.
Amazing.
So let's go ahead and let's add a data source. So we can go here. You can add from Google Cloud Storage, Amazon S3. You can add from just an HTTPS source or a local file. I'm going to use a Google Cloud. So if we look here, I'm just going to go back for a second. And I'm going to pull in some data that I've got living in Google Cloud. So I've got this electronic store data that I can bring in. It's a Google Cloud URL. The cool thing about Rill Developer is that, as it's running locally, so you don't really need to trust Rill with your credentials or trust us. You don't really need to upload your data to our cloud. You can just run this locally, and if you've got a Google Cloud URL like this, the credentials are inferred from your local environment. So one of the nice things about running things locally, again, is we can kind of rely on the security perimeter of the laptop. It's often a blocker, I think, when you're working with cloud services to try to have that cloud service talk to your cloud bucket. You've got to sort of do a bunch of permissions. But most developers have in their local environment permission to look at various databases and data resources. Okay, so we're going to add this events electronics store Parquet file. It's not huge, but I think it'll be a good example. So we're going to import that. And the moment we import this data, we get this preview of that actual data set. We can see here it's not a huge data set. It's about almost 1 million rows, 800,000 rows. One of the things that Rill Developer really prides ourselves on is providing incredible visibility, observability into the data itself. So as a data analyst, something I often look at is what's the distribution of these different fields, right? So I can see here I've got user ID, product ID. This makes sense if this is a typical e-commerce data set. Those are integers. Price is a number. I can look at this. It's pretty interesting. There's obviously this outlier here. Most of the prices, are pretty low, and you've got this $164,000 item. I don't know what that would be, but Rill provides really. I can click on any of these and get kind of introspect what these fields are. Just get a sense of what this data is. Here, this is actually encoded as a varchar. And one of the first things I want to do here is I want to clean up this data. I want to turn this source into a model that I can build a dashboard on. So let's go ahead and do that. I can click here and create a model off of this source. Rill automatically creates a model. It's very simple. It's a select all from that source. But the truth is, this is for Rill, we really think about building operational dashboards. Time plays a really important piece here. So if I want to go all the way to dashboard, you see here, Rill says, add a timestamp column to your model in order to generate the dashboard. So we've got to build a timestamp. And so right now, the problem is that event time is encoded as a varchar. So let's just do some quick, write some quick SQL on the fly. But the cool thing one of the cool things about Rill is that keystroke by keystroke, I'm validating this. And what I'm going to do is, and again, this is using DuckDB on the back end. I'm actually going to clean up this this timestamp column. This is a very common thing. We've got event time. I'm going to pull this out and turn it into. I'm going to extract basically the timestamp from here. So you can see here already. Let's actually put this first. You can see here, right? It's actually turned this into its timestamp. Let's call this as timestamp. And you can see Rill, again, each keystroke I type, we actually validate whether this is a valid expression. If I make a mistake here, it says, hey, we failed to parse this, this is not working. So that fast feedback loop we think is, really important for, for folks, who are doing analysis, right? We're often we don't want to have to submit this and wait. And because this is all running locally, it's incredibly fast. Another cool thing. So let's actually, I'm going to also use some syntax that I love. I know Snowflake supports this, but so does DuckDB. We can do this select all and exclude. So what I've done is I've reformatted event time, a varchar, into a timestamp. So now we've got a timestamp. And you can see it shows up as a timestamp. But then I've also excluded that column from my model because I don't need it anymore. So I've just converted this into something nice. Other nice things. So I'll just show off a few things about the ergonomics of DuckDB. No problem with the trailing commas, no issue. A lot of other SQLs would fail there. Another cool thing that we really like is you can actually put the from statement at the top. When you're doing a lot of modeling in Rill, you can actually chain models. It's very common. You really just want to be able to see that on top. You don't want to have to hunt through your code to find where that from statement is. That's kind of the most important. It's just kind of like putting the year first in a time stamp. You really want the biggest, most important thing first. So I love that syntax. Okay, let's go over here. So what's cool is now that we've got a timestamp, we can generate a dashboard. So instantly, with one click, I've now built this e-commerce dashboard. It just says total records, and it gives me kind of the different dimensions of the data. So what Rill has done here is we're extremely opinionated about the kind of dashboard that you may want to see. We believe that most people just want to look at essentially key metrics of their data and be able to slice and dice those key metrics by different dimensions. And in SQL, those metrics are often aggregates, right? So this is just a count star. And the nice thing is I didn't have to design this dashboard. This dashboard is an artifact. In fact, every model is actually a dashboard. Every data set is a dashboard. These things are actually kind of symmetric, if you will. And so the goal in Rill is to kind of go in and actually carve, refine that dashboard, refine that data set. the critical task here of the data analyst is actually not to design dashboards, it's to design these metrics. The dashboard design, just like a journalist shouldn't design the layout of a newspaper, they focus on writing the content. The content of dashboards are metrics and dimensions. And so we're going to go here and I'm going to actually add, some additional measures here. So let's do, let's just do revenue. That's a pretty important one if I'm an e-commerce shop. So we're just going to do sum of price. And we can go back to the dashboard and bam, we can see revenue. And the cool thing about this is this timestamp, we automatically built this, auto-generated this time picker. We can look at the revenue for the last 2 weeks. We can look at the revenue for the last 30 days. I can start to zoom in and look at what category code is selling the most here. And see that, video cards apparently are, selling a lot. This stat I think might be from a long time ago, but, and, I can start to do some other things. So let's go in and let's look at, very quickly, I'll go in and show, let's do kind of unique customer count. That's going to be account distinct user ID. And then I can, start to chain these up and do, let's do, ARPU is a very common one. So let's do sum of price over count of distinct user ID. Let's see if this works. It should. Go to dashboard. I have to delete this one. And then let's do this final one, which is just maybe average basket. I'll do sum of price over count star. I know what that one. Okay. Yeah, that's right. Sum of price. Okay. So now I've built this dashboard, and this took me just a few, really just a few minutes. And really, what I had to focus on was I really was focusing on the SQL here. That's the model that I built, and then this. While I was doing this in the UI, this edit metrics. If we actually go back and look here, we can see that. If I go into my dashboards directory here, and forgive me with my Emacs, you can see this is just a YAML file.
Yeah.
So, so the cool thing about this is I can actually now I can actually commit this to Git, and I can share it with a colleague of mine, and they can collaborate on these dashboards as well. So I won't go through a Git process here on the demo, but what I will do is I'll show, if I go to my own GitHub page, I think I've got, Driscoll. Yeah, let's see here. I did commit yesterday one of our, here we go. So you can see here's in Git, and I could actually, again, the dashboard here, here's the model. And so again, this is now under Git control. Other people can collaborate on it. And you essentially get a governance, right? As we know, the power of making infrastructure as code, the power of making BI as code is now we've actually got a Git workflow for governance, for auditing. When these dashboards are pushed into production, ultimately, with a publish command, we can now have some controls. We can do rollbacks, right? If we make a change to the dashboard that we don't want, we can roll back to the latest version. We can look at, which of our, which of the engineers is proposing a change. We can start to put some hooks on the Git repo and auto approve certain changes. Let's say like changes to the description, but do some checks on any changes that might expand the size of the model. So in my experience with dashboards, oftentimes, when the ETL and the dashboard code and the database code live in different places, there's a lot that's lost kind of moving between different tools. Our thesis is that, tools code that works together ought to live together. So this last mile from the source into the database, the transformation of these sources into models with SQL, and the transformations of these models into dashboards with YAML, all of that code ought to live together in a single repo. And it just provides incredible observability and just a lot of simplicity. So, at Rill, we've had a version of this dashboard running for our customers for a long time at scale. Some of our customers are Fortune 50 telcos. Comcast is a customer of Rill's today. They are sending tens of billions of events through our system every day. But the way in which today that Rill Enterprise product is updated, it's quite challenging to make a change to the data models, to the dashboards. It's not at all productized. And so the inspiration for Rill was, we know that we've got thousands of customers using this dashboard, the end product, but the journey to get to this dashboard and the complexity of updating this dashboard was just very heavy. It wasn't self-serve. So we had a self-serve dashboard that our business personas were using, but the actual act of developing those dashboards was not self-serve. And so Rill Developer is Rill's mission to make the creation of these dashboards self-serve. And frankly, also to scale it down. Because while Rill, again, we work at scale, our cloud enterprise product is running on a massive columnar in-memory, mostly in-memory engine, which I know you know of. Apache Druid is the backend. Rill Developer is running at microscale with an embedded OLAP engine, DuckDB. So we try to sort of scale down the product and make it much more accessible to folks. And actually, DuckDB can scale quite a bit. We actually feel that DuckDB can probably get, you can safely get into the tens of gigabytes with the DuckDB backend.
Yeah. And not everyone is a Comcast, right? I think as a matter of fact, there's a lot of companies that have small data and are just looking to extract value and insights from that data. So what struck me that Rill is incredibly fast, right? Like the way the dashboards render. In I don't want to dump on other products, but that same experience I don't think is possible today with other products. If you just like update these dashboards on the fly, you would just look at spinning wheels all the time. But can we unpack all the different steps you just showed us a little bit and then understand what is the skill set that I, as a customer, as a user of Rill, need to have? And I kind of want to use your analogy of, or your three different, what do you call them? Sources, models, and dashboards. Those are.
That's right.
Those
right
are
here,
steps,
yeah.
or yeah. So
yeah.
I download Rill, right, the developer edition. And you said it connects to an object store like S3 or Google Cloud Storage. How do I get data in to S3? And I know I'm like asking obvious questions, but let's unpack this a little bit, like how this would work.
Right. So the recently I was reading this. There's a website out there talking about the ways in which product architectures should be designed for apps. It's called it's kind of a manifesto. I think it's slightly old, but it's called the 12-factor app. I don't know if you've come across this before, but it's a great, it's really a great kind of framework and methodology for thinking about, how we ought to design apps to be scalable and, maintainable. And one of the core concepts there is kind of obviously separation of concerns. For Rill, there's really kind of there's really three pieces of infrastructure that come together to form a Rill dashboard application. The first one, quite naturally, which we saw, was the actual Rill binary that we downloaded with that curl command. So that's the runtime, effectively. which has DuckDB embedded into it. And that runtime also has a web server built into it. We're using Svelte. We actually have a combination of Svelte.js for rendering the web app, and Hamilton Elmer, who's our head of applications, is absolutely, I would say, obsessed with making the Svelte transitions beautiful and frankly functional and fast. So Svelte is really powering the application rendering. We've got a Golang, I guess you'd call it middleware, and that Golang middleware is then translating calls from this application, this web application, to the DuckDB embedded DuckDB database. Now, so that's the runtime. Effectively, all of that together, we consider that the runtime. This application. The second piece of code we have is the configuration code. That's what we're looking at when we think about a project. The idea of a Rill project is effectively code that defines, we go to this easy commerce, dashboards, models, and sources, right? So this is basically the BI as code. This is a separate, it's not code that is executed per se, but it configures and parameterizes these dashboards. The third bucket of code, or I guess I'd say the third piece, more importantly, is, and this is, maybe I should have started with this, but it's arguably the most important, is the data, the sources of the data. So that for Rill, the source that we focus most on is cloud object stores. So if you want to get your data into Rill today, there's really three places that you would probably put it. You would probably put it in a today we support GCS, Amazon S3, and HTTPS. Local files is really just for people who want to get started quickly, but that's not really a product. There's generally not a production use case for local data.
Yeah.
So we have a CLI for Rill. If you obviously I use the UI, but there's a CLI where you can actually import data from that S3 bucket. Mm-hmm. If in a production system, what Rill will do is essentially treat let's call it Parquet files living in an S3 bucket as the source of truth, and it will continuously model data out of that S3 bucket into Rill, materialize that model, and provide a rendering of that dashboard. So the idea is that the bucket is the source of truth. We believe typically that bucket may evolve over time. People may add, if you're the electronics store, you may every hour, maybe every 10 minutes, you may add new Parquet files to that. And Rill, when deployed, a Rill dashboard will orchestrate. We think of it as lightweight orchestration. We will orchestrate data out of that bucket and incrementally update this store model, which in turn will provide essentially an update of the dashboard.
So the S3 bucket or the object store is effectively the first node in your DAG, right? Or the piece of data, right?
That's exactly right.
Okay. And so as a user, I mean, as Comcast, I probably have hundreds of developers, if not thousands, but I still need to find some sort of data pipeline that gets me the data into S3, right? Like from my whatever systems, right? And so that's the skill I still, like some data engineering skill, right?
Absolutely.
But that's becoming easier and easier.
Yeah, and we think of ourselves as like a last mile, last mile of transformation, right? So we're not going to be, we have no, I think, illusions or delusions, I would say, that we're going to compete with Dagster or Prefect or others who are Astronomer, Airflow, right? We're not going to go out there and manage extremely complex DAGs.
Yeah.
But if you can, and let's face it, this data is already, quite simplified, right? The starting point for Rill is you've essentially got tabular data, right? This may, in a real world use case, yeah, there's probably quite a lot of work that went into actually um, extracting, you know, uh, data from a Stripe, payment transaction JSON blob, and then pushing it ultimately into, a price, a price field here that then got, pushed into the data lake.
Right. And so I think we can agree that getting Stripe data into S3 is a solved problem. There's many companies out there who do
Right.
that.
That's right.
Open source, proprietary, right? And
Yeah.
so that's sort of step number one. What I found interesting is, like, now that you picked that up from a Parquet file, you were giving it names. Like, I mean, we see it here: user ID, product ID, and then when you, as you're writing, you were writing your models.
Yeah.
So that reminds me of the concept of a semantic layer, right, or a
That's right.
metrics layer,
That's right.
which today is done, in the so-called modern data stack. There's a dominant tool that does that, and I think what we've seen is an explosion of models,
Yes.
right? And so I think, which then has given birth to other tools that sort of track the metadata or track the number of models and make sure that, whatever model pulls data from a specific column is pulling it from the right column, that the column is up to date. And what you're saying is, like, let's just simplify that.
Yes. Absolutely. That's right. Yeah, I think, and there's no question that there's a set of use cases where Rill is not going to be the right tool. Um, you can see here, we're extremely opinionated on this journey from data to dashboard. But for we believe for maybe 80+% of use cases that we've come across when it comes to building, again, we call these operational dashboards, right? This is typically continuously evolving data that companies want to be able to put their finger on the pulse of their advertising operations, their marketplace operations, their infrastructure operations. We use Rill internally to monitor many of our cloud services. So for those use cases, we think that, as you said, combining, not having these separate services for a data catalog, a semantic layer, uh, a a data model, and the kind of last mile ETL, bringing all these things together does just makes life easier for the developer.
Yeah.
And you can see here, this is very much a very lightweight semantic layer, right? We could add here some basic descriptions of, total revenue in USD,
Right. Right.
and those become, you can just mouse over it and you've got some basic information there. And over time, this may get more complex. Uh, but the nice thing, again, it being, this is because there's code artifacts underneath here, you actually don't even need to use Rill Developer to make these changes, right? You could go in, it's very inspectable. It's not like this semantic layer is kind of buried in a tool and you can only edit it through that specific tool. I think that's the challenge with a lot of BI tools, certainly like historically, like Tableau, is that sometimes the model definitions or some of these annotations, semantic metadata, was buried in the tool itself.
Right.
And the only way you can make changes to it was to go into that tool. And in our case, because it's YAML, anyone can go in and actually, in some ways, this becomes the semantic layer is, accessible here. So the semantic layer is just a YAML file, right? I
Right.
could go in here and edit. I could edit it in GitHub
Well,
myself if I
in
wanted to.
the old, you mentioned Tableau, not to dump on them, great product, but they had this thing called, or still have this thing called extracts, right? And I think it was all based on the assumption, like, oh, it's storage is very expensive, so we're going to handle it, we're going to ingest it, right? And that led sort of, like, people were looking at old data, old in parentheses, in quotation marks, but what you're saying now is that, I mean, the minute you update your model, you just get the fresh data directly to the source, right? Like, because it is an S3 and
That's
that's
right.
where you get it
That's
from.
right.
Yeah. Yeah.
Exactly. That's right.
And so now I'm the user. I'm the Comcast. I'm the what would be the title of that person? Is it an analyst? Is it a financial analyst? Is it an engineer? Like who? I've solved the problem of getting data into S3, and now I can actually get out my data. I can start writing these models.
Yes,
I need to know SQL, right? I need to have
that's
some
right.
knowledge of SQL. Who's that person? Who's that person? Is it a person that sits in engineering? Is it a person that sits in finance? Both? Like
Right.
who is it?
Yeah, it's a great question. I think, you know, the the thesis that we're driving for with Rill Developer is really to target a software engineer who is looking to develop some data muscle, um, more so than we're looking to target a data person who's looking to develop kind of engineering muscle. And so the idea here is that, as we talked about, getting your data into a cloud object store in Parquet format, that actually does require some engineering muscle. And if we really want to radically kind of simplify the creation of these dashboards, we are kind of shifting the dashboard creation process left, right? Everyone's talking about shift left. Um, this, in some ways, allows a software engineer who's been asked, someone working at a fast growing, we see this often. It's the fast growing companies often haven't invested in data teams. They haven't invested in a whole constellation of, data SaaS offerings. Um, and so there's often a VP of engineering, sometimes just a data engineer who says, has been asked by the business team, hey, we need a dashboard. We have no idea what's going on in the marketplace. Yesterday, our payment API broke. We need some better observability. And so,
Yeah.
our target really is software engineers who are looking to flex some data skills.
So I want, and if they're lucky, if they have a data engineer, I think the world has evolved. But 5 years ago, the first hire would have been like a data scientist or an analyst,
Right,
because companies wanted to be data driven. And then they found out, well, for that data scientist to be productive, you need data. Who's the
right,
persona? And they don't know how to write data pipelines, right? And so
right.
you need a data. So let's assume you're lucky, you have a data engineer. So essentially, you're saying is I'm bringing analytics engineering to the software developers, but I'm doing it in a radically simple way because I'm consolidating all these functionalities that today are broken across 6, 7, 8 different tools into one tool, right? That's
That's
really
right.
it.
That's right. And I think today, what I think we've seen is a lot of times in the earliest stages of companies, when again they're fast growing, they need observability. The business team says to the engineering team, "Hey, we need to get some dashboards of what's happening here." The tools that the engineers often reach for are going to be tools like application performance monitoring tools. So Grafana and Datadog and even New Relic are often the first generation of dashboards that you see emerge in a company. And our feeling at Rill is that those tools really aren't quite a perfect fit for kind of business process monitoring. They're great for monitoring servers. They're great for giving you kind of a time series KPI of, your P95 latencies. But when you want to do the kind of investigatory, exploratory, slice and dice analysis that hopefully you got a flavor of when I showed off the dashboard, you need it's a different architecture, and it's more of a BI architecture. And that is what Looker and Tableau, tools like Superset and Redash, open source BI tools, that is what they provide. But those tools are much more complex to get running. And so we're trying to kind of give the power of BI with the simplicity and ease of use that Grafana has, and
Yeah.
target that software engineer.
So this is a super interesting topic, and I want to spend some time on that right now, because it's a discussion that we're having here at Some Engineering as well with users and investors. And in fact, there's one company here based in San Francisco. Let's say that company's in the hospitality business, and they're using Datadog right now um, to pump data into an analytics store in the cloud. And they know, and the team that's doing that is an infrastructure engineering team. And they know it's wrong. But let's talk about, you said something like those are actually not the right tools. It's something I definitely see. The knee-jerk reaction is to go something like an APM tool to acquire data. Maybe there's a little bit scripting involved, right? To call the APIs. So let's why it works. It's super janky, but is very limited, very janky, very costly. Can we talk about a little bit why this is not a good approach? Why there's a better approach?
Let's well, if we kind of part of it comes down to kind of the architecture of these systems. And so if you think about the underlying architecture, the underlying data storage engine of most APM tools, things like Prometheus, for instance, they are time series databases. And the nature of a time series database is that you have effectively what sometimes people refer to as a tag that describes the time series. You want to call it, let's talk about this hospitality business. They might say for a particular hotel, right? They might say hotel, and then the time series metric is check-ins, customer check-ins. Well, for every hotel, you have to have a tag that you track. What you often see if you look at people's actual dashboards or what they developed is they will end up creating these hyphenated tags that contain all of the combinatorics of dimensions that they want to look at their business. So they'll have, hotel name dash, California dash, 4-star dash, right? Owned or operated, right?
Dash, city, room type dash.
So New Relic and Datadog and Grafana, people end up with these, in the underlying data store with just basically tag explosion. So this is the curse of dimensionality. So with high cardinality data, you end up with this explosion of tags, and it's not the right architecture. What you really want to do is you want to actually separate these things out and have really multi-dimensional time series. And so for that, you can't use something like Prometheus. You really need to use what we've traditionally referred to as, an OLAP engine. And if you want speed, of course, you can use just a regular relational database. But and so that's where I think engines like ClickHouse, Druid, obviously DuckDB at low scale, these OLAP engines are what you're going to find under the covers. Every BI tool essentially has an OLAP engine underneath.
Yeah. What is the mind shift that these infrastructure or engineers in general, what is the mind shift they have to make to realize that they're using the wrong tool? Because it's not a message you want to go in with like, hey, you're using the wrong tool. Because the argument is you're dealing with really smart people who know what they're doing. And they actually know, like, hey, this is like a crutch, but it's working fine enough,
it's a hack,
right? It's a hack. It works well enough. It's like, why change? It's working, right? And I'm not paying the bill. So what is the like? What do you see Rill users like? What is the mind shift where they say, no, this is a different new world, and so I'm investing into this, and then I'm departing from my old ways of doing things? Like, what are the things that people need to realize?
It's a great question. I think, in some ways, all innovation or all change comes from pain, right? So the real, the real question is, when do they confront pain? When do they encounter pain in their current solution? And at small scale, that first hack together dashboard showing, this is the performance of the e-commerce marketplace, over time, probably they don't encounter very much pain at that first hack together dashboard. I think there's a few places where I think the pain starts to show up. Almost certainly, as the business users come in, typically what business users ask is, let's add more dimensions to this dashboard. I want to be able to look at our e-commerce revenue, I want to be able to cut it by product category, by product SKU, I want to cut it by store ID, right? As you add these dimensions, as the business folks ask for more dimensions, I think that's where that curse of dimensionality starts to crop up. And that's probably very typically we've seen that's where the pain is really felt. Because the manifestation of that is things get slow. If you ask people about their dashboards, what often happens is what works at small scale is performant. It's fine. As they scale and they encounter this dimensional curse, tag explosion, suddenly the business user is like, hey, I can't, I can't use this dashboard. It doesn't work. It doesn't load. And so that's the first pain. And then I would say maintenance, becomes a pain. And so if you're having to kind of hack together, push your data into these time series, engines, sometimes they don't always have great support for SQL, for instance. And so there's just a lot of scripting going on that can be brittle, your pipelines. So I think in terms of like, you start to think about a mature data, kind of mature data processes, having, kind of these application performance monitoring tools starts not to scale if you're looking to do like joins with various different data sets, and then you want to update the definitions of things. You just have a lot of different pieces in different places. And so I think that complexity starts to be a real headache.
Yeah, that's what I see as well, or I hear when we talk to users, right? They what they tell us, like, look, yes, we know how to do this, but it stops scaling at some point, right? It just
Yes.
doesn't work anymore. And
Right.
especially also if you work with the users who are API or who are familiar with using APM tools, what I see is when they embark on this BI venture, or analytics venture, they need to become experts in much more than just being a developer,
That's
right?
right.
They
That's
need to
right.
be an expert in the data source. They need to be an expert in data engineering. They
Right.
need to be an expert in the domain, because you need to slice and dice the data so that the business user gets value out of it. And it's very quickly you're talking about a unicorn type of developer that just
Yes.
doesn't exist, right?
That's right. That's right. And exactly. And I think that there's this chasm, right, between um, engineers and analysts. Now we've got analysts who know how to use Tableau, and they know how to write LookML models. But if you're an engineer that's just trying to get a dashboard up for, your CEO is banging the table, says, I need a dashboard, yesterday. The idea of having to teach yourself LookML, just, and install Looker, and then go out and get a cloud data warehouse up and running, all of that effort just to get a simple trend line, right? So it's a lot of heavy lift for an engineer just to get something that ultimately is pretty simple.
Yeah, yeah. Okay, so I think we covered a lot of ground. We obviously covered how Rill works, um, how we compare to some of the elements of the modern data stack today.
Mm-hmm.
And then this conversation around engineers and analysts, and maybe that as the closing thought, it almost feels like we're coming full circle, right? 10 years, 8 years ago, we started with this notion of BI, analytics engineering, and say, hey, it's time to apply software engineering principles to working with data, right?
Yeah.
And that all happened with the rise of cloud warehouses like Redshift, Snowflake, and BigQuery. It almost feels like we're coming full circle now, where infrastructure and operations, they generate an enormous amount of data,
Mm-hmm.
where we need to apply those principles. And so now it's the software engineers that go back to the learnings of the analytics engineers and apply that to their own data set. Is that
Mm-hmm.
something, I mean, would you subscribe to that point of view? And do you see that?
Yeah, I mean, I think we're we're having this convergence of cultures, right? I think it's everything is related to everything else, but I think probably the big shift, probably the biggest change in the world of data in the last few years, one of the biggest changes certainly, I think, was the rise of DBT.
Yeah.
And what DBT did is it introduced an entire group of analysts to the idea of kind of code-led software engineering practices. Defining their pipelines in code that could be validated and checked in with Git. And so I think that was a big moment in the data space where suddenly analysts who for a long time were spending time in sort of tools like Power BI or Tableau or Looker, they never really were quite exposed to the these DAGs, these pipelines, even though those pipelines were so critical. And of course, a big part of related to that, I think that was the movement from ETL to ELT, right? So we that shift, doing the transformation in the data warehouse versus doing the transformations outside the data warehouse, doing that in SQL versus doing it in Scala or Java or Spark. I think that's what's kind of driven this convergence between, so that the analysts are becoming more familiar with software engineering practices. They have to think about pipelines and quality of the pipelines, because those pipelines are now being written in SQL and they can edit those directly. So I think that's been a very healthy evolution. I think maybe what I'm arguing is that in the same way that, again, the analysts have become more like engineers, I believe that engineers can become more like analysts. I think that there's nothing stopping a relatively smart engineer from, who knows a bit of SQL, from actually getting, dangerous enough to be able to build dashboards themselves.
Right. And the need is there today, right? Except the tooling isn't there, and that's where Rill comes in.
That's right. I think everyone needs dashboards, right?
Yeah.
Dashboards are really, they're just observability over data sets. That's what a dashboard is, right? It's just another way to look at, and I think that every engineer, we all know that engineers crave observability into the systems that they're building. It's an essential feedback loop, and it's one that is I would say a persistent challenge, and dashboards actually represent a very powerful way to get that observability, not just into the business data. I think we've seen with Rill, it's quite useful for infrastructure data. We use Rill to monitor all of our AWS and Google services. We pump all of that data into to an S3 and GCS buckets, and we model it together, and we run our dashboards that give us. We actually have up to the minute cloud cost monitoring at Rill using Rill. So our head of finance can look and see exactly what our gross margins are. Every company, especially in this environment, cares about how much revenue comes in and how much does it cost. What's my cost of revenue, cost of goods sold? We can monitor that in a very granular way, using our tool.
And I think I always like, this is the second episode of this session. I would say even very meta. You're using Rill to monitor Rill.
Yes,
but the point you're making is that there's now a different audience, your CFO, a non-technical audience, who cares about this operational data, who cares about infrastructure data, which previously was the domain of just the engineers, right? But it's now, because of digitalization and all of that, it's becoming business relevant now. Yeah.
Yes.
Fascinating.
I think that's maybe as the looking forward, I think that I think gets to the essential point, which is that there's so much rich data, so much telemetry, as we've started to instrument, the economy, every business process increasingly has kind of a digital twin, has a digital stream somewhere that's tracking it. And so as companies digitally transform every aspect of their business, there's a log file sitting somewhere that tells you, whether people checked into the hotel, whether they used the phone, or whether they bought something at the hotel gift shop, or any action that a customer takes on a platform, or interaction with a product or a service. All of that now is instrumented somehow, somewhere. And so much of that data is sitting in log files and S3 and GCS buckets. And so the opportunity is, how do we make sense? How do we build intelligence over that data without having to go through 25 steps?
Right. And the use case being generating knowledge and insight versus
Right.
finding production critical events that may prevent a user from booking the hotel room, right? Because that's the main purpose of these APM tools today, and monitoring tools. That's what the data is used for.
Right.
But no one is saying, okay, now that we have all this data, let's take a step back to figure out
right.
what's really going on and what we can do.
Exactly.
Mike, fantastic discussion. Thank you.
It's great to be here, Lars. Thank you for the time. And I know we didn't talk at first, but I know you and I share a place in the mountains that we ski at. So I look forward to seeing you on the mountain slopes in a couple of weeks here.
We do, and I look forward to that too, to a beer on the back deck. And for anyone who listens or watches this podcast, that place is Sugar Bowl, and you will find Mike and me on Fridays and Saturdays and Sundays, usually there on the back deck, hanging out there. It's a great environment.
Mike, it's a great place to talk data. Thank you, Lars.
I will come back and ask you for a second episode for the Rill on Rill, but for now, thank you so much.
I look forward to it. Thanks, Lars. Have a great weekend, and thanks to all your listeners.
Thank you.
Bye-bye.
Bye-bye.